Hello students. So students, in the previous class in this chapter, that is chemical reaction and equation, we were talking about the different types of a reaction and in which we had completed that of the decomposition reaction and we were understanding the displacement reaction. When we talk about the displacement reaction, basically the displacement reaction is, the name itself says displace, it means one of the element will take the place of the other or it will remove that of the other element's place. Okay, that is what? That is a displacement reaction. In this, the thing that we have to understand here, that is, in this reaction, basically, the more reactive element will displaces the less reactive element. And how we will come to know that this element is more reactive than the other with the help of the reactivity series. So in the reactivity series, the students, the metals which are kept at the upper position, they are at more reactive than the metals which are below to these metals. So in which we will know that the sodium and potassium, they are supposed to be the most reactive metals. On the basis of that only we are able to understand the displacement reaction, in which we have seen, if suppose we will take a copper sulfate solution and add zinc granules in it. So you know that the color of the zinc granules is silvery white and that of the copper sulfate is blue solution. So when you add the copper sulfate in that, when you add the zinc granules in that of the copper sulfate solution, you will see that after a few interval of times, it starts, the color of the copper sulfate, the blue solution starts fading and finally it will become colorless. Okay, so this is basically happens because the zinc, it displaces the place of a copper sulfate and in place of the copper, and instead of that it will form a zinc sulfate and copper is removed along with it. So reddish brown copper will be formed and the solution will changes to the other. So this is the displacement reaction. Next one, if suppose instead of using that, if we will use the magnesium and add magnesium powder in it, the same thing we will see that the color from blue changes to colorless. It means it starts fading and the reason is that magnesium displaces the copper. Now these two reactions, they said that the zinc as well as the magnesium, they are more reactive than that of the copper sulfate solution. Then the next one, students, we have seen that if you will take an iron fillings and you will add that iron nail in it, you will find that the color of the copper sulfate from blue changes to green. And the reason is that now this iron, it reacts with that of the copper sulfate and displaces the copper, and instead of that it will form the iron sulfate, okay, ferrous sulfate, and the color of this iron sulfate is green. So this happens because iron is more reactive. We have seen an example of that of the iron when added to the hydrochloric acid. There also there is a formation of a ferrous chloride, which we call as the iron chloride, and this happens because iron is more reactive than that of the hydrogen. We will see some more examples, students. Like you see, if suppose we will take chlorine, Cl2, and this chlorine reacts with that of the lead iodide. Okay, so sorry, potassium iodide. Potassium iodide. Potassium iodide. Then there is a formation of a potassium chloride, that is KCl, and I2 will be released. Now we are able to balance it. Here it will be 2 KCl and 2. Why? Because Cl2, 2 Cl is there. Here only 1 Cl is there, students. K is balanced, but I is here 1 and here I is 2. That's why we have put a 2, so that the potassium and iodine both will be 2. And here when we put the 2 here, so Cl2 will, chlorine will become 2 as well as the potassium will also become balanced. Okay, so you can see here that when the potassium iodide reacts with that of the chlorine gas, then chlorine displaces potassium, it displaces that of the chlorine displaces that of the iodine, and instead of that it forms a potassium chloride. So potassium iodide was there and it is displaces by that of the chlorine here, students. Okay. Now moving on, and we will see one more example, students. So suppose we will use that Fe plus, it is not Fe but Fe2O3 plus Al, then what you will find? You will find that there is a formation of Al2O3 plus Fe. Now you see here, student, this is what? This is the ferric oxide. Okay, ferric oxide. Okay, ferric oxide, or we will call it as a iron third oxide. When this iron third oxide react with that of the aluminium, or aluminium is added in this reaction, what happened? Aluminium, it will displace that of the iron base. This proves that aluminium is more reactive than that of the iron, so it displaces that of the iron base, and instead of that it will form the aluminium oxide. Okay, so we can write it here. It is aluminium oxide. Okay, so we can say that the ferric oxide will be displaces by that of the aluminium oxide, and iron will be formed as a residue. So this is what? This is also an example of a displacement reaction in which we can say that aluminium is more reactive than that of the iron, students. Now moving on, and if we will take a copper oxide and add that of the magnesium powder into it, then what happens? CuO is what? It is copper oxide. Okay, it is in the form of a solid. This is copper oxide. Now in this copper oxide, when we will add the magnesium powder, then what happened? Magnesium being more reactive than that of the copper, it will displaces that of the copper, and instead of that there is a formation of a magnesium oxide, and copper will be formed as a residue. It will be reddish brown in color. So this is also an example of a displacement reaction. So these all are the different examples of displacement reaction, students. Okay, so I hope you have understood here that in the displacement reaction, the thing that we have to understand is the more reactive will going to displace that of the less reactive. Okay, more reactive will going to displace that of the less reactive. Only then this displacement reaction can take place. What does that mean? It means here this is a reaction. So if suppose we will make it like this, that magnesium oxide when react with the copper, then what happens? You can see here, students, this reaction is just opposite to that of the first one. Here we have taken the copper oxide, and in that we have added the magnesium in it. So we have seen that magnesium being more reactive displaces the copper's place, and instead of that there is a formation of a magnesium oxide and copper. Okay, but what happens here? So you see that copper is less reactive than that of the magnesium. So there will be no reaction occur. Okay, because it is not having it is less reactive, so it is not able or not capable to displace the magnesium place. So here it will be no reaction will takes place. It will remain as it is. So no reaction. Okay, no reaction will take place. So these all are what, students? These all are the. So students, these are some of the examples of that of the displacement reaction. Moving on, and we will see the next type of a reaction, and that is the double displacement reaction. Now you see here, before we go, let me tell you one more thing here. and that is you see, when we were talking about that of the displacement reaction, and now we are going to discuss about that of the double displacement reaction. Double displacement reaction. So double displacement means what? Here the exchange of ions take place between the reactant students. That's why it is called as a double displacement reaction. When we were talking about that of the displacement reaction, there what happened? One of the reactant displaces the place of the other element. Okay, so there a single displacement occurs. Although we never use the word that is single displacement, instead of that we will simply use the term that is displacement itself. Okay, but there only single displacement occurs. So we can say that is a displacement or a single displacement reaction. So whenever the term displacement comes, you will understand that here only the single element will displaces the other one. That is a single displacement reaction also you can say. In case of a double displacement reaction, there is exchange of ions take place between the reactants. So on the basis of that, we can also write the definition in which we can write it that those reactions in which two compounds reacts by exchange of ions to form two new compounds are called double displacement reaction. Is called as double displacement reaction. Okay, so when basically what happened when the two reactant, they react together, and in this one, the two compound when they react, there is an exchange of gases occur, students. Okay, this exchange of gases occur, exchange of ions occur, and due to the exchange of the ions, the product that formed is a new compound, is a new product, and this is called as the double displacement reaction. Basically, what happened in a double displacement reaction? This reaction occurs in the solution. So you will find that when the product is formed, one of the product is a kind of a precipitate. Okay, so this most probably happens with that of the double displacement reaction. So we can write it that it usually occurs in the solution, and one of the product being insoluble precipitate out. In which form, student? You know that in the form of solid. So one of the product, it comes out in the form of a precipitate. Okay, so this is an example of a, okay, so this is is a double displacement reaction. So in this reaction, precipitate is formed. Let us try to understand the double displacement reaction with the help of an example. So one of the examples, student, that we are knowing we have done in the experiments of class 9th also, in which you see that if we will take a sodium sulfate in the form of a salt, and we will make the aqueous solution of the sodium sulfate. Then in the another test tube, we will take the barium chloride, and again we will make the aqueous solution of barium chloride. How we will make the aqueous solution, student? Simply by taking the salt and adding distilled water in it, shaking it. When it will get dissolved, that is the aqueous solution. Okay, so the aqueous solution of the barium chloride and aqueous solution of the sodium sulfate. Now these two are what are the reactant. When you will add one of the that of the barium chloride to that of the sodium sulfate test tube, then what happen? You will find that there is a formation of a precipitate, and here that is the precipitate is of a barium sulfate. It is a white precipitate, and the solution which is present just above to that of the precipitate is of a sodium chloride. So let me write the reaction. Basically the reaction of the sodium sulfate and barium chloride is, this is sodium sulfate, it is in the form of a aqueous solution, students. Okay, plus barium chloride also we will take in the form of a aqueous solution. Sodium sulfate and barium chloride. Sodium sulfate and barium chloride. This will form barium sulfate plus sodium chloride. Okay, so barium sulfate is in the form of a solid, and sodium chloride is in the form of an aqueous solution. And why I am writing this? Because barium sulfate will form some white precipitate. Okay, so there is a formation of a white precipitate. When you keep it left and stir for a few times, then you will find that there is a precipitate is formed at the, it settled down at the bottom of the test tube, and that is of the barium sulfate, that white precipitate. Okay, so now you see here that how this is a double displacement reaction. Basically there is an exchange of gases occur. How? You see that here this sodium in the form of Na positive and barium chloride, which is a Ba positive again. You see what happened? Sorry, Ba plus 2 positive. Okay, so what happens here, students? This sodium ion reacts with that of the chlorine, and this barium reacts with that of the sulfate, and thus there is a formation of a barium sulfate and sodium chloride. Now you can look at here that this sodium is basically +1, and when it reacts with the chlorine, you know that the chlorine is having the charge that is the -1. It means the valency is 1 here. Chlorine valency is 1. So ultimately they will form NaCl. So here the formation of a sodium chloride happened. What happened when the barium react with that of the sulfate? Barium ion react with the sulfate ion. So sulfate ion is -2. It means their valency is also 2. So when they react together, it will be Ba2SO4 whole twice, or we can simply write it as BaSO4, which is what? Which is the white PPT formed in this double displacement reaction. So you can see here that there is an exchange of the ions occur between the two compounds. The sodium comes to the barium side, and the barium ion, it comes and join or react with that of the sulfate. So exchange of the ions happen in this double displacement reaction, as well as formation of a precipitate occur. Okay, so this is one of the example of the double displacement reaction, student. Now let me balance it also. Sodium is 2 here, sodium is 1 there. So instead of that we can write it here, that is So sodium, you can see here we had balanced it that sodium is 2 here, and now that of the chlorine is also 2. So chlorine is balanced, barium is 1, barium is 1 at the product side also, and sulfate is 1 and sulfate is 1 here also. Okay, so this reaction is now balanced. Now moving on, and let us see some of the more examples related to that of the double displacement reaction. So you see what happens when the silver nitrate reacts with that of the sodium chloride. So you see that when we talk about the silver nitrate, that is AgNO3, silver nitrate. Silver nitrate, that is AgNO3, which is an aqueous solution, then when it reacts with that of the sodium chloride, which is also an aqueous solution, so you see that there will be formation of a sodium chloride AgCl plus NaNO3, that is this is the silver chloride, and sodium nitrate will be formed. So this is what? This is silver chloride, and this is, students, white precipitate. It is in the form of a white PPT, and this is what? This is sodium nitrate. Okay, silver sodium chloride. Sodium chloride. Silver chloride, sodium nitrate, sodium chloride, and here it is a silver nitrate, students. Okay, so this is an example of a double displacement reaction. Now you can see here that how here this silver, it reacts with that of the sodium, student. So silver is having the charge, silver ion is +1. When this silver ion reacts with that of the chloride ion, that is Cl minus, you see that there will be formation of a silver chloride. So one of the silver from this side, then this ion get exchanged the other one and react with the chloride ion, and there is a formation of a silver chloride. Now you can see here that both of them is having one valency, and ultimately the formula which is formed here is AgCl. What happened in case of a sodium nitrate? How sodium nitrate is formed? So basically this sodium ion, that is Na positive, reacts with that of a nitrate ion, and there is a formation of a sodium nitrate, that is NaNO3. So one of the ion reacts with the other one, or we can say that both of the compound ion, they exchange each other, and thus there is a formation of a new compound happens here. Okay, so this is what, this is also an example of the double displacement reaction, students. And you can see here one more thing, and that is there is a formation of a white precipitation. So in both the cases, whether we have taken the case of a barium sulfate and barium chloride and a sodium sulfate, in which there is a formation of a white precipitate of barium sulfate happens, or we have taken the reaction of the silver nitrate to the sodium chloride, there is a formation of a silver chloride, which will also forms the white precipitate. Okay, so this is then example of the double displacement reaction, students. Now you can see here that here not only the double displacement happens, but in both the cases there is a formation of a precipitate. So we will call it a double displacement reaction, as well as we will use another term for it, and that is the precipitation reaction. Precipitation reaction is what? A reaction in which there is a formation of a precipitate occur, that comes in the precipitation reaction, students. So we can also write here the definition of a precipitation reaction also. So Now this we will write a precipitation reaction. And the definition is, that is, any reaction in which an insoluble solid and insoluble solid is formed, that separates from the solution, solution is called a precipitation reaction. It's called a precipitation reaction. Okay? It's called precipitation reaction. Okay? So the reaction in which the precipitate is formed, that is called as a precipitation reaction. Moving on, and let us see some of the more example of the double displacement reaction. So we have seen here two reaction, students. Let us see some of the more reactions of a double displacement reaction. So if we look at the reaction, and that is of a barium chloride, BaCl2, which is a barium chloride, when react with that of the copper sulfate solution. So CuSO4. CuSO4 is what? It is an aqueous solution. Barium chloride is what? This is also an aqueous solution. So this blue color, when the barium reacts with that of the copper, then there is a formation of a barium sulfate plus copper chloride is formed. Barium sulfate and copper chloride. Now you can see here what happens here. This barium, which exists in the form of a 2+, which is a barium ion, reacts with that of the sulfate ion, and there is a formation of a barium sulfate happen, and this copper ion reacts with that of the chlorine, and there is a formation of a copper chloride happens. So this is an example of the double displacement reaction. If we look at the other example, students, so what happened when copper sulfate reacts with that of the hydrogen sulfide, that is H2S. Hydrogen sulfide means H2S only. Okay? H2S is what? It is a gas. So what happened when this gas is passed in the copper sulfate solution? You will find that, student, that this hydrogen will react with the this sulfate, and there is a formation of a H2SO4 plus this copper will react with that of the sulfur, and there is a formation of a copper sulfide. And this copper sulfide is actually black precipitate. So there is a formation of a black precipitate. In this case, you know the student that a barium sulfate will form the white precipitate. So here the formation of a black precipitate happens, and here the formation of a white precipitate happens, students. Okay, so in both the cases the formation of a precipitate happens. We have seen one of more examples, students, in which we have taken the lead nitrate. And this lead nitrate, when react with the potassium iodide, there is a formation of a lead iodide, which is a yellow precipitate, and this will also comes in a double displacement reaction. Let me write the reaction here. So we have taken the lead nitrate, which is PbNO3 whole twice, and when it reacts with the potassium iodide, this time the solution, you know that it is colorless, when it reacts with the potassium iodide, then there is a formation of PbI2, which is what? Which is a yellow PPT, that is yellow precipitate, and potassium nitrate will be formed as a product. So you can see here that this lead is in the form of +2, lead ion, react with the iodine and form lead iodide, and this potassium ion reacts with the nitrate, and thus there is a formation of that of the KNO3, that is potassium nitrate, student. That is potassium nitrate. There are some of the reaction like that of the neutralization reaction where there is no formation of a precipitate happens, like when the sodium hydroxide reacts with that of the hydrochloric acid, there is a formation of a sodium chloride and water, and the sodium chloride, there is no such kind of a precipitate happens. It means in a double displacement reaction, it is not compulsory that there is a formation of a precipitate, but most probably in most of the reaction precipitate formed. Okay.